In this example, we are going to take the Python for loop and we're going to use it in several examples, several very small examples, just to illustrate the syntax of the for loop and pretty much how easy it is to use. So to begin with, I'm going to show you several tables. A table is a common thing we run across that we see quite a bit and use quite a bit. So let's use our program with a for loop and let's make some tables. So the first thing I want to do is to make a table that has distances, and we're going to look at distances in miles and distances in kilometers. So let's put a comment here that illustrates what we want to do. Okay, we want to make a table of distances in miles and kilometers, and if you don't know the conversion, then 1 mile has 1.62 kilometers. So we just want to make a table then. We'll let the miles go from, say 10 to 100 in increments of 5 or so. If we're going to make a table, it would be good to have the headings printed out. So let's just print to the screen the table of distances that we're going to make. So we'll give it a title. And then I'm going to print out just the word miles and kilometers. And we'll work on the spacing between these just as a trial and error to make sure we get the column headings in the right place. Now, let's put the for loop in that will allow us to make the table. So we'll put the for loop here. And notice the syntax. Okay, we're going to have miles is going to be the variable that changes. So as long as miles is in the range of 10 to 105, stepping by 5 each time, then we're going to take the value for miles, multiply it by 1.62 to get kilometers, and then we will just print the miles and kilometers to the screen. So this loop is going to start with miles with a value of 10. And we're going to add on 5 each time. And we'll stop when we get to here. Now the question is, what is here? And in Python, remember that you always specify one more than what you really want, because it doesn't count that last value. So what this is really going to do, it'll go from 10 up to 100 in increments of 5. So we will get a table then, and we'll have the miles and we'll have the kilometers output. Okay, so now this is pretty easy. Let's just run the program and look at the output. So I'll bring over the output, and let's look at the table that we made. Okay, so here we have the table of distances that's written out, and then we have the headers for the 2 columns, and then we have the miles in this column on the left, and we have the kilometers on the right. Now, the first thing that jumps out at you will be these long numbers that we see here. And that's because we didn't do anything to restrict the formatting for this. So I'm going to show you that next. But if you ignored that for the time being, then you can see mile starts at 10, and it does stop at 100. Okay, it does not do 105. Then we just multiply miles times 1.62, and we get the equivalent in kilometers. Okay, so that's a nice table. Now before we leave and go on to another example, let's look at how we can format this so that we don't get all of those extra digits over here to the right. Well, the number that's printed out, or the variable that's giving us all those extra digits, is the kilometers part. So we want to do some formatting with that. So I'm going to show you the format, and this is just something that you can make note of. I'm not asking you to remember it and reproduce it, but it is something that helps us to reduce the number of digits on the right and keep the output looking clean. All right, so the thing that we have to do, here's just our kilometers over there. So think about this. We want to format the kilometers, and you can use format, and you can use any variable that's a number, a real number in here. But the weird thing is this notation over here on the left, and I know that's kind of odd looking. So if you'll just make a note, write it down, and go look it up when you need to format something, then that'll be fine, at least in this course. So here's how you do it. We have something between double quotes. Okay, so we have double quotes on both sides. Okay, then we have the dot format over here. Inside the double quotes, we have a left curly brace, we have a colon, and we have a dot. Okay, so we'll use those 3 things. Just remember them. Then the next thing here, you can choose how many digits to print out. So if you only want to print 2, then you put 2 here. If you wanted to print 5, you'd put 5 there. If you wanted to print 1, you'd put 1 there. And the next thing is the letter F, which indicates that that's a real number. So then we'll close that with a right curly brace, and then we'll get a nicely formatted output. So I know that's kind of cryptic, but that's what we have to do in order to get a nicely formatted output. So now let's rerun this, and we'll see the output once again. So now we have the output, and now the table looks a lot nicer. So by using the format, and let's see if I can move that over a little bit. When we're using this format notation, then that restricts the number of digits that we're trying to print to 2 digits to the right of the decimal. So anyway, there you go. So this is a nice little for loop, and there's only 3 lines in it that we can use to generate a table. Well, there are a lot of things that, a lot of different tables we can make that would be useful. So let's move on, and let's make a table of temperatures. So we will take temperatures in Celsius, and we'll convert them to Fahrenheit, and we'll also convert them to Kelvin. So let's do that next. Now I could start all over with a different program, but I'm just going to do all these together in one program. So let's paste in some lines of code. So if I do a print with a double quote \n/n, then that skips 2 lines, and then the print statement itself skips another one. So this is going to skip 3 lines from the last output we got from this table up here. So we'll put spaces between our tables, or some blank lines. Then we have another table we want to make. So we'll print out our table of temperatures. Then we have 3 columns this time. We want to print out the Celsius, and we want to print out the Fahrenheit, and we want to print out the Kelvin. So we can also do this very nicely with just a small for loop. So let's go get the for loop, and let's put it in here. And let's just start with the first line of this. Okay, so we'll get the first line, and let's put it here. So here is the beginning of the for loop. So Celsius is going to be the loop control variable, the variable that changes. It will start at 0, and it will go to 101, and it will go by 10 each time. So once again, if I left this to be 100, then it wouldn't actually do the value 100. It would stop at 90. So if you wanted to go to 100, you've got to have at least one number here, or I could put 110, and that would work as well. But 101 will do it. So that means it's not going to do 101, but it will do 100. Then, afterwards, we have to do a couple of things here. So inside the for loop, and don't forget the indentation. I didn't mention that again, but that's critical. What we need to do is to calculate the Fahrenheit based on the Celsius value. So Celsius is going to change 0, 10, 20, 30, 40, and so on. So we'll need to take that value and we'll convert it to Fahrenheit. And if you need to look up the formula, you can, and you may know it already. But we need to put that line here. And we need to be careful about that spacing right there. So every line has to have the same number of blanks, otherwise it'll give us an indentation error. So the conversion formula, if we want to take our Celsius value and convert it to Fahrenheit, then this is it. It's just 9 divided by 5 times the Celsius temperature plus 32 degrees. So that'll give us the Fahrenheit value. We also want to calculate the Kelvin, or the absolute temperature. So we just take the Celsius value and we add a number to that, which is 273.15, and that gives us a Kelvin. Okay, now when I pasted that in, it didn't line up, so I've got to be very careful and make sure those line up, otherwise it'll give me an indentation error. So there, I have the Celsius value, starts at 0, goes to 100. I've calculated the equivalent Fahrenheit, and I've got the equivalent in Kelvin. So now we want to print out a table that has 3 columns. Okay, so we let's go get the print statement to do that. So I'm going to copy it, and if I'm going to do the formatting, it's going to be kind of long. So let's go ahead and put that in here. And here it goes. So I'll line it up, and then let's go through it. Okay, the first thing I want to print out is just the Celsius temperature. And that's going to go 0, 10, 20, 30, 40, so on. So that's where we get Celsius. It comes from the range here. Then I need to put some space between here. Now notice I'm using commas. Okay, so I just want to put a bunch of spaces. So I have a double quote, I've got some spaces, and another double quote. And we just have to use trial and error to make sure we have the right number of spaces in here, because I want to print out the Celsius column, then I want to move over a certain amount to the right and print out the Fahrenheit value. Then there's some more spaces here, and I print out the Kelvin value. Okay, so using that notation from up above, I'm going to limit the number of digits to the right by using this notation. Okay, so I just explained that. So I'm going to format the Fahrenheit value using the dot format with Fahrenheit in parentheses. Dot goes here, and then this formatting instruction goes over here. Okay, then I have a comma after that. I have some spaces again, and then another comma, and the last thing is going to be the output of the the output of the Kelvin formatted the same way. All right, so that's a pretty long line, but I'm just formatting each number that comes out for the Fahrenheit and Kelvin. Okay, I don't need to do any formatting for Celsius because I know it's going to go 0, 10, 20, 30. It is not going to have a fractional part, so I don't need to format that one. Well, let's run the program and look at the output from this table. Okay, so let's bring over the output. And there it is. Okay, so let's move this up. The top table, that's just the table of miles and kilometers that we just did. So here you see we did skip some lines, 1, 2, 3 lines, really 3 lines. I didn't lie. And here we have our temperature of tables. Now, I'll admit that the spacing here between the columns, I had to run this a few times to get it right. So you just have to run it a few times and make sure you get the spacing with the number of spaces here correct. Okay, so when you do that, then it's trial and error. So it's good enough for now. So here's the output we get. Okay, so Celsius starts at 0, it goes up to 100, and we multiply the Celsius using the appropriate formula. We get the degrees Fahrenheit, so it's easy to tell. 0 Celsius is freezing in Fahrenheit, and 100 degrees Celsius is boiling in Fahrenheit. And then we just add the 273.15, and that's the Kelvin temperature. The absolute temperature shows up over here. So here we have, again, a small for loop. It only has 4 lines this time, but we generated a useful table. Now, you can pick how big or how accurate you want the table by specifying the starting value, the ending value, and the increment in between. And this could be anything that you want. If we wanted a smaller range, for example, let's do this with a smaller range. Let's suppose we wanted to go from 40 degrees up to 50 degrees, and I'll have to do the 51. Remember, if I did 50, it would stop before it got to 50. And let's suppose I only want to go in 2-degree increments. Okay, so now this is going to be a more accurate table over a smaller temperature range. So now let's look at the table that we get from this. Let's bring over the output, and here you go. So the Celsius starts at 40 this time, and we're incrementing by 2. So it goes 42, 44, 46, 48. It stops at 50. And we have the equivalent Fahrenheit value, and we have the equivalent Kelvin values. So it's up to you. How accurate do you want to make this table? Or over what range, I guess I should be saying, do you want to make this? And it's up to you. You can pick whatever range you want, and you can pick whatever delta between temperatures that you want, and you can generate this table. Now, let's move on, and let's just look at something more general. We can use this for loop to generate all kinds of tables. So this illustrates a couple of them. Now, just look at one more example. So I'm going to skip 3 lines again. So I'll print out that same line, \n, and then I'm just going to make a table of some formula here. So I'll print out a table of calculations, and this will be simple. I'm going to print x, and I'm going to print the square of x here. So let's look at how we can do that with our for loop. Well, this will be pretty easy. We just want x to go from some beginning value to some ending value. So let's just get the for loop, the first line of our for loop, and let's put it here. And I want some space here, so let me move that up a little bit. So I'm going to choose the following here. I'm going to let x start at minus 15, and I'm going to make it go all the way up to 15, except I know it's not going to go to 15. It's going to go to 14 when I do that. So in fact, let's make that 16 instead. So now it should go to 15. But I want it to go in increments of 2. So it will start at minus 15 and then go to minus 13, minus 11, and so on until it gets to 15. And I want to print out x squared. All right, so I just need to calculate the value for y. So I'm going to put the value or the calculation in here and make sure that we have the correct spacing. So I'll move it back to the origin. I'll hit the tab key just to be very careful about that. So, the easy way to get x squared, you can just multiply x times x. Now I've got two values. Okay, so in the table, I have the value for x and the value for y, or x squared is what I'm calling it here. So we just need to print out those values. So we need a print statement for that. So we can put the print statement in here. So I'm going to print out x with a comma, then I'll put some space to separate the columns, another comma, and print out the value y. So now this is just going to give me a range of the values of x and the values of x squared, which will be y. Now let's run the program and let's look at this output. Okay, we have the results. And although it's not lined up real nicely, I'm not going to worry about that for now. So we have x on this side. You see it did start at minus 15. And as we add 2, it goes more positive, and it finally ends up at positive 15 down here. So then we have the value of x squared. Okay, so of course you get a positive value when you multiply negative numbers by themselves or square them. So the range of values that we get in this table is shown here. So you may have any equation that you want for this. This is just a really simple one, but if you have any other equation that you want to produce a table for the values, then you just substitute that equation in here, and then this for loop is going to generate a table that shows you the x value and the resulting value that you get. I should do the y over here from the equation. And always you can start set the beginning value, and you can set the ending value, and you can set the difference between them. The only thing you can't do here is you can't use real numbers up here. Okay, so for example, I couldn't do 15.5 to 16.7 with 2.25 because the range does not accept those things. All right, so that's not allowed. And if I try to run this, you can see that it will give you errors. So let me show you that. Okay, we have the output, and you can see the red lines here, the red type. So that means you have an error. So the error is this. It says, no, you can't use real numbers with range. You must use integers only. So we'd have to come up with a different way if we wanted to make our values go in increments that are less than 1 up here. All right. Now, let's look at another example, and let's turn to our turtle graphics for this next example. Since this program is starting to get long, and because I'm going to do some turtle graphics, which is going to bring up the turtle graphics output canvas, I'm going to delete all the examples I just did and just put in the new examples that have the turtle graphics. So I'm just going to highlight or select this whole thing, and I'm going to just delete the code that we've done already. So now we'll have a clean program in order to do the turtle graphics. And I just see I mistyped that information up there. All right, so let's put in some code for a turtle graphics. And let's talk about the hexagon. Okay, so we did an example earlier where we just made a hexagon. In order to use the turtle graphics, we do need to do these things. We have to import the turtle library. So that should be at the top. And in fact, all of this stuff really ought to be at the top of the program before we do any print or anything else. So I'm just going to rearrange things a little bit here. And let's put the import at the very top. I like it up there. So we will do import turtle. That brings in our turtle graphics library. And in order to open the canvas for the turtle, we have to do turtle.getScreen. Then, if you don't want to type turtle over and over again, then we can use a shortcut by setting some variable t equal to the turtle.turtle. So that just lets us type a T instead of typing the turtle every single time. Now, we want to make a hexagon. So let's initialize some things to begin with. I don't want to draw to begin with, so I'm just going to bring the pen up, and I want a line that's a little bit thicker, so I'm going to set the size to 2. And I'm going to start the drawing by going over to this location. Okay, X is 0, Y is 200, so I'm just going to go up 200 pixels before I start to draw. Now, let's look at what we did before when we were just creating the initial hexagon. So if we put the code in here for that, we used the forward and the right commands. So we put the pen down, then we want to move forward, and when you're putting the pen down and you move forward, it draws a line. So then we'll turn right 60 degrees, we'll move forward again, and it draws a line. And we'll turn right again and move forward. So you see that this is repeated. The forward and the right is repeated over and over again. So we could easily do this same thing with a loop. But first of all, let's look at the hexagon that's produced by these commands. So I'll bring over the turtle canvas. Here it is. And there you see the hexagon. So I went up straight, well, I won't trace it out. You see, we got a hexagon here. Now let's do the same thing, but let's use our for loop to do the hexagon instead of all those other commands. So let's stop this. And I want to replace some of that with a for loop. Okay, so we will put the pen down as we need to do if we're going to draw, but then we can just use 2 of these statements instead of having to copy and paste them 6 times. So let's put our for loop right here. So now we can do it this way. You can use the range with just one number by just putting one number here in parentheses. And what this is going to do is it's going to tell you how many times you want to go through the for loop. And n is going to take on the value starting at 0 all the way up to this value minus 1. So 0 up to 5. And if you start counting at 0 and you go to 5, then it'll go through the loop 6 times. Okay, now we don't need to do all of those. We just need to do one of them. So let's take away all these extra copies and let's move this up, and we have to format it correctly. Okay, so let's tab, we'll put the tab key. We'll hit the tab key here and here to make sure that that's in the loop. So again, the indentation is critical in Python. So now we have a loop that will do the same thing that we did with more lines of code earlier. So n starts with 0, it goes up to 5. So we'll move forward and we'll turn right, and we'll do that 6 times. And when we do that, we get a hexagon. So now, using this shorter amount of code, only these 3 lines, let's run the program again, and we will still get our hexagon. So let's bring over the output, and it looks exactly the same as the other one did. But now, we are using the for loop, so we don't have to write so much code. So here's a lot of examples of how you can use the for loop to save time in coding and shorten your programs. Let's look at a couple of more examples where we're going to use the turtle graphics, because let's face it, turtle graphics are definitely fun. So let's close this and let's look at another example. Now, since I don't want a lot of designs on my canvas, then I'm just going to erase the hexagon, and let's put in another for loop here. And I'm going to go back to the origin, so 0, 0. And this time I'm going to have n in the range starting at 50, it goes up to 200, and it goes in increments of 50. Okay, well, again, I know I would go to 150 here instead of 200, so let's make this more than just 200. Let's call it 210, and that will ensure that I go 50 to 100 to 150 to 200, so I'll go through the loop 4 times. All right, I want to draw a sequence of circles this time. So let's get the code that we need for that. We have we just need to draw the circle, so we just need the circle command. So what is that? Well, it's just called circle. All right. So if we want to draw a circle, then I'm going to draw the circle, but I'm going to give it the value n this time. So n is going to start at 50. So it's going to draw a circle with a radius of 50. Then it goes to the loop again, and we add 50, so it goes to 100. Then we use 100 to draw the circle. So we're using this in as it progresses through the range, 50, 100, 150 to 200, and we will use the in here to draw a series of growing circles. We've got a small circle, and then we'll get several larger circles around it. All right, so now using this for loop, let's look at the canvas and see what kind of design we get. So when I start the program, then I'm going to bring over the canvas so you can see it draws a circle, another circle, and a third circle, and then here's our fourth circle. So using the for loop, we have this design. Now, the one thing that bothers me is I've got this solid line right there. So when I wanted to bring back the total to 0, then it drew a line down here to 0. So let's fix the program so I don't get that, and then we'll redo it. The problem comes because I think I left this line in here. I don't want to go to 0, 200. I did that when I was doing the hexagon. So I don't want to do that. So let's take that down. And let's see, is everything else okay? Pen size 2, pen up, pen down. There's really no need to bring it up and put it right back down again. So I'll just set the size to 2. And we are not making a hexagon anymore. So let's make a circle. So let's just put that in there. So we'll make a change to that. We're not going to see that on the canvas anyway. All right, now I think we can redo this, and we'll get the same design without that extra line there. Okay. So let's bring over the output. So watch it draw. Now we don't have the extra line. And by using the for loop, we get a design. And wow, you can just use your imagination now with this, and you can make all kinds of designs using your turtle graphics. One thing I'd like to do is I want to see if I can make a bullseye out of this. Okay, they all start at 0, 0. All these circles do. So it goes up, completes one revolution, and then it starts the new circle here on the circumference, okay, on the edge of the circle. So then when it does the next larger 50 increment circle, it goes there and comes back to here. So if I want this to be kind of like a bullseye, each time that I draw, I'm going to need to move this down a little bit. Okay, I got to move it down by the radius of the circle. So let's add that line of code into our for loop. So I want to paste that in. So let's put that here. And let's make sure things are all nicely aligned. Now, when I move, after I draw one circle, then I want to move down by the radius of the circle in order to get ready for the next one. But I don't want to draw a line as I'm going down there. So I'm going to move the pen up. Then I'm going to move down here, and then I'm going to draw the next circle. So since I am bringing the pen up here, then I do need to put it back down again. So let's add that in here. Okay, T.pen down, and you have to use the parentheses. All right. So now I will get a bullseye design. So let's look at what we get. So now you can see we get a circle, then another concentric circle, and so on. So by modifying it a little bit, we now get a bullseye design. So you kind of get the idea. So if you want to play around with this and draw different kind of figures, I mean, it's up to you how you want to do this. I think I want to do one more dealing with circles, and then we'll end this video. So for this design, I'm going to use this for loop. So I'm going to count 0, 1, 2, 3, which means I'm going to go through the loop 4 times. That's just the way Python works. I'm going to draw a circle that's 100 pixels in radius, and then I'm going to turn right. Then I'm going to come back up and draw it again. So I'm going to do this 4 times. What kind of design is that going to make? Can you imagine what that's going to look like? I mean, clearly I'm drawing 4 circles here, but I'm also rotating each time by 90 degrees. Well, let's look at what we get. Let's run the program and look at our pretty design. So we'll pop that up here. And here we go. So there's one circle. We'll rotate to the right, draw another one, rotate, and then we draw a third one. So we get this design. All right. So we get a nice geometric designs out of these things. So then we just use a simple for loop that had only 2 lines within it in order to make this. Now, depending on how good you are with Turtle graphics, you might be able to fill in some colors for these things as well. But you get the idea. The usefulness of the for loop, is very powerful. So you can do a lot with only a very few lines of code if you have a for loop. So there are several examples then. So I am going to close the video here, and we will probably see the for loop coming up in additional videos. But for now, we are going to just stop.